Hey guys, so we are doing today's daily lead code today, and let's read the question. The question is minimum cost to make at least one valid path in a grid. Given a n grid, each cell of the grid has sign pointing to the next cell you should visit. If you are currently in this cell, the sign of grid ij can be I1, which means right, 2, which means left, 3, which means lower, 4 means up. Notice the three, notice that there could be some signs in the cells of the grid that point outside the grid. If we initially start from the upper left 0, 0, we have to reach a valid path on the grid is the path that starts from upper left 0, 0 and ends at last cell. Following the sign of the grid, the valid path does not have to be the shortest. Okay. The valid path does not need to be the shortest. You can modify the sign of the cell with cost 1, and we can modify only once. Return the minimum cost to make the grid that has at least one valid path. Okay. So I am here. I can go here in 0. I can go here in 1. Here I can go here in 2, 2. But I can go here in 0. I can go back here in 2, which will be greater than this, so I don't want to do that. Okay, I think I have an idea. I can have a visited memo, let's say, and I'll visit this. Okay, now the cost of this will be 0. Cost to reach here is 0. Cost to reach here is 0. Cost to reach here is 1. 2. Okay, okay, okay. So let's do a DFS, void solve. Okay, and I have int I comma int j. Now, if I is equals to m minus 1 and then j is equals to n minus 1, return 0. Okay, because here we will, if we are already here, we return 0. That's the case. Now, int m is equals to grid dot size. Let's copy this. N equals to grid of 0 dot size. Cool. So now, if So let's make the grid also, comma this. Now this dot grid is equals to int this dot grid is equals to grid, and this is equals to vector int of size m comma vector int of size n comma -1, or int max. 0, 0. Get rid of I is equals to 1, then I can move the right direction or left direction. Right direction means J plus plus. Width of I J is equals to min of, and do I want to do int max? What is the has to then E, I mean, min of I is of I. Let's just int 27 is equals to min of answer, comma, moving to the right. Right is solve of I, comma, j plus 1 to I smaller than 0, or j smaller than 0, or I is equals to m, or j is equals to n, then Newton, then E7, because m and n, that will not come to that, right? Newton. Okay, and now if it is 2, then we go to the left side. J minus 1 as if it is 3. Then for 3, we go I plus 1 j. Oh, we go I minus 1 j. Okay. Now, once all this are done, answer is equals to min of. Should I do 1 plus here, or it's return answer, and let's do 1 plus here of answer, comma, 1 plus solve of. Let's do this. Answer, comma, solve, comma, 1 plus solve of this, comma, 1 plus solve of this, comma, 1 plus. One, two, three, four. Answer, comma, solve. Okay, I j plus 1, I j minus 1, I plus 1 j. Cool. So first one is this. Second one, we have 1 plus, but no one. For the third one, we have 1 plus, but no one. And fourth one, we have 1 plus. So this should give us. I smaller than 0, j smaller than 0, I is equals to m, j is equals to n, return max value, I is equals to n minus 1, return 0. Let's do a little bit of debugging. I can see why we need the visited. Probably that is the problem. So if vis of I j not equals to 10 is 7, return vis of I j. I think this will be wrong. I have a feeling that what I'm writing is not the correct way to look at this solution, this question. What is the problem? This is very bad. Like complexity wise, this will be very bad. Two is right. No, it's maybe n square only. This will return it. Yep, 25. Hmm? Returning 10 raised to 27 is the problem. Why is it a problem? Why is 10 is I smaller than 0? No, I is equals to j is equals to s equals to n. True. Return 27. If I change all the 27 to 25, I don't get it. Let's look at the editorial now. TP the extra. The extra would have been good. PFS would have been. This is what I wanted to do. One. Okay. Okay, we could have done a DQ. They could have taken a Q. In that queue, I added this. Now I add these two. This was the best plan. So I'm here. This is 0. This is 1. This is 0. So this is 1. This is 0. This is 1. This is 0. This is 1. Okay. This will take 2. This all of them are at infinity. Okay. Mm. 0, 1, 0, 1, 0, 1, and 1. Okay. Now all these four are here. I'll ah, so should I take a priority queue? I think I will, yeah, Dijkstra will be priority queue solution, but this will not. PFS solution would be. I like this PFS solution a lot. Okay. Start cell 0 at 0, 0 in front of the queue. Okay. Tickets never fill the minimum cost. Okay. 1, 0, 1, 0, 1. Okay. At the left one to the start, the right one to the end. Okay. At the right one to the start, at the bottom one to the end. Okay. This is lower, so I've added to the start this. I was at 0, 1, 0, 1, 0, 2 at the start, 1, 1 at the end. Okay. At 0, 2, 1, 2 at the end. Cool. At 1, 0. Okay. Makes sense. 2, 0 at the start. How does this go about? These are the directions, rows, columns, min cost. Okay. DQ dot push front. Okay. Min cost of 0, 0, 0. Okay. This is the cost of going to that node. Is valid means, okay, it's if it's a valid row and the cost is, okay, if the cost is 1, makes sense, makes sense, makes sense. Cool, this is it, I guess. Hello, I think lead call.